Turns out that's where we began. Right smack dab where the blacktop ends. Yeah, the field's got hay, hay's got barns, barns got lost for watching them stars falling right out of the clear blue collar sky. Yeah, just a loving this life on the dirt roadside of the county line. Ain't rich, but we're doing alright. Got my honey on my arm, Jesus in my heart, living like a lyric out of fishing in the dark. Yeah, we work hard.
We carry out work on plant diseases, especially wheat and oil crops, and any other crop that farmers plant within our mandate regions. But nationally, we look at wheat and oil crop like sunflower, rapeseed, and soybean. So in the section at Njoro, we have quite a number of activities. One of the activities is to carry out surveys in farmers' fields and even on trial plots. And why do we carry out surveys? It's because we want to monitor varieties that are grown by the farmers out there, if they are diseased or they are not diseased. So if they are diseased, we are able to advise the breeders that such and such a variety has a problem, so the breeders can also improve on their breeding methods. On surveys and surveillance as an activity, we actually travel to farmers' fields in all the 4 major wheat growing regions, that is South Rift, Central Rift, North Rift, and Mount Kenya region. So we travel, we go to the farmers' fields and stop at farms randomly. Once we enter into the wheat farm, we have to move around the field, and before we do that, we have to take coordinates of that particular field. Coordinates, what I mean is we take the elevation using the GPS, the Global Positioning System. We take the elevation, we take the latitude, and we take the longitude. And after that, we move around the field, we scout to see if there is any infection of rust. This time is particularly rust, whether it is yellow rust or stem rust or leaf rust. Then while doing the scouting and getting any infected plant in any field, this information we enter into a form, and in that form we write, you have to enter the person doing the activity and where it is being done. Because it's a global activity, you have to indicate the country. So we have to indicate it's Kenya doing the activity, and then we enter the name of the farm or the area where we are sampling. We also enter the name of the variety if we know it, and if the growth stage at which we are sampling, and then we do the assessment to see how much disease is there. If there is no disease, we also record this farm had no disease. We also check if the farmer has sprayed that particular field, and then we also do that recording. And it's not only rust that we look for any other disease that may be affecting or infecting that crop. We also take it as a record. We walk into the field and randomly check at the plants to see if they have any infection.
After scouting the farm for the diseased plant, we do identify one, and we collectively come and do the scoring. Scoring simply means that how much has the disease affected the plant, and in our scientific term is known as the disease severity. The first thing we do is that we identify the part, and while scoring, we score the whole plant, we just don't score part of the plant. So that will give us a range of how serious is the disease in that particular farm. After that, we cut the disease. After scoring, we cut the part that has been diseased, and that is the stem.
So what score are you giving that one?
Sorry?
What score are you giving this one?
It's a collective work. I'll give 40%.
Give it, okay, it's 30S.
30S.
Yeah, severity of 30S, which means the percentage is 30 and the plant is, the variety, that particular variety is susceptible.
Fine.
Step is that we take the infected plant, which is that particular part of the stem. And you do that using a sterile scissors. And our interest is not the whole part of the stem, but just the sheath that has been affected with the spores. So that's what we do. Whatever I'm doing, I'm just getting the sheath, the stem sheath, and we place it in a specialized bag known as a glycine bag.
To go to another field, we have to sterilize we sterilize our hands using ethanol, 70% ethanol. Everybody sterilizes his or her hands. Okay, we sterilize our hands and then the pair of scissors before we move to another field. Where we have put the sample is labeled details of that particular field as recorded from the GPS readings. During the surveillance, when we collect the rust inoculum, we are supposed to use it in the greenhouse to do race analysis, find out if that race or the race UG99 in the field has changed or it is still the same. In here, when we are doing here, we will be able to know it is still UG99 or it's another race. So we come to the greenhouse, we have special lines that we use for race identification. And these lines, they are about 20. So we plant each line in a pot. And there's a prepared pot which has the media. The media here is the vermiculite, serving as the soil media. So we plant about 20 seeds per pot, per line. We finish one line, then we go to another line, cover it nicely so that it's not exposed on the surface. So we do that for all the 20 lines and label every line in every pot. Yeah? We label. After labeling, we water the plants, we water the planted material, and then it's carried into the germination room. Today, the plants should be at least 2 to 3 leaf stage. This is the time now we have to inoculate the seedlings. And for inoculation, we remove the seedlings from the growth room and put them into the inoculation chamber. This is our inoculation chamber. The rust that we collected from the field is normally bulked into. Okay, we keep it in this type of vials. You can see this is the rust that was collected from the field. Then what we do is we get distilled water to inoculate the plants, but we don't do it directly on the plants. We put on the inoculum at a distance and a little bit, maybe 30 centimeters above the plant. So with a nice mist, you keep on spraying, you keep on until when it lands on the seedlings. When this is done, we carry the inoculated seedlings set in a way that the conditions are favorable for the development and infection and development of the disease. But here, okay, at an average of about 25 degrees for stem rust and leaf rust, yellow rust is a little bit low, and almost 100% humidity. And then this chamber has to be humidified. Relative humidity is up to 100%. And the temperatures depends on the pathogen or the disease. For example, stem rust, the temperatures have to be between 18 and 25. That's the same to leaf rust, but yellow rust is lower than that. Yellow rust does well in a cool temperatures. So we make sure that the chamber is well watered. This time we are not watering the plants, we are just humidifying the chamber. Now when we are finished, we make sure it is well sealed. It is well sealed, and the plants have to be there for 24 to 48 hours. We expect the infection to have started. After 28 or 48 hours, we will remove these plants and take them to the another growth room where they are supposed to be here for 14 days. Every morning they have to be humidified. Just come and spray every morning until when you start seeing the spore coming out or germinating. So on the 14th day, the infection, if it has taken, the plants are ready for reading.
These are the plots that were initially planted in. So there are different types of plots having different types of seedlings. So we do score per plot or per pot.
Per line.
And that is per line. And while in the field we score in terms of percentage, seedling stage we have a score from 0 to 4, 4 being the highest. And once again, while scoring, we do score collectively. His score has also to coincide with my score. So in this case, I'm going to give a 3+. What do you say?
Yeah, it's good. It's 3+ is okay. I can see it is 3+. Yeah.
We move again to another pot online. And as you can see,
that one I can see it is a flake. Is it a flake? Is it a flake or it's a 2?
This is a 2.
Okay, that one we give it a 2. Yeah. Then read this one. Read this one.
This is a good case of a flake.
Oh, it has some flakes.
Yeah.
Yeah. So,
You can see.
okay, that is a flake. Yeah.
What do you mean by a flake?
A flake means the disease was trying to infect, but the plant is resisting. It's a resisting mechanism. Yeah. It's just resisting. It doesn't want to be infected.
Good.
But at 4, it is susceptible. At 3, it is susceptible. At 2, it is not susceptible. It is resistant.
Okay.
Yes. But a 0, there is a 0 and a flake. 0, it is completely clean. A flake, it's, you know, it's some yellowish. I'm fighting back. I don't want to be infected.
Okay.
Yes. So when the scores are over, then we'll look at the whole. We'll look at the whole scoring per line or per set, and then we are able using a scale. Yeah. Or using is it a diagram we use? There's a scale we use that we will group the 3s, the 2s, and we'll be able to say, okay, this race is still UG99, or it's another race. Yeah. And if they are seedlings just for screening, you just want to know whether those particular lines are resistant or not. So again, you go through and then you say, if you have given a line at 3, you know this line is susceptible at seedling. If it is a flake or a 1 or a 2, you know it's resistant, and you can carry on with your breeding or with your research. Yes, but it doesn't mean that when you get a line susceptible at seedling, it's a bad line. It's just that the major genes it is holding the major genes. But when you carry to the same plant, when you carry it to the field, or when you do adult plant resistance, yeah, you may get this line at a certain stage. It's not infected. It's only infected at seedling. So those are the lines we refer to adult plant resistance. That at seedling they are susceptible, but at maturity they are less susceptible, or they are actually good.
This is a pathology laboratory, and the main activity that we do here, apart from wheat research, we also accept and we do plant disease diagnosis of other crops that are grown within this particular region. And there's always a step that we do take from receiving the sample, doing the plant diagnosis part, and giving the advisory services, which are also called control measures, and to that particular plant that will have been received. So in this case, we do have 2 samples here. When a farmer comes, we always advocate for a farmer to bring us a whole plant so that we may look the whole plant for the diseased part of the plant. And we have the inventory book, whereby we do record the plants that have been brought, and the details that are going to help us do plant diagnostic first. And the first part we do record is the type of crop that has been brought into this particular laboratory. And in our case, this is a sample of a grape crop that we have received from a farmer. The second thing that we do record it is what is the name of the farmer, because this will give a track record of that particular disease and the region that is being grown. Third, we have the locality that will also help us as plant pathologists to know the prevalent disease that is around that area. And lastly, it is the percentage of the damage of that particular crop. That's why we are advocating for a whole crop before we start isolating the diseased part of the crop. When you compare this with a normal leaf, a normal plant leaf, this is not normal, because we have got some part that is being chlorotic. And in our case, we will assume now that this is the part that it is severely diseased, though we don't know which type of disease, which type of pathogen is causing this particular disease. So the first step we'll do before we move to incubation part, we are going to isolate this particular part that has been diseased. And I'm going to use a pair of scissors that has been sterilized. And I'm going to cut into pieces this particular part of the leaf that has been diseased. The second part, after taking that part that has been diseased, we'll move to fume hood, whereby we are going to work under sterile environment so as to sterile this particular part of the plant that has been diseased. This is a sample of the wood that we do use, and the main agenda of using a wood is simply to work in a sterile environment with an aim of not introducing any foreign pathogen apart from the pathogen that we'll be working with on. And I'm going to start using 70% of ethanol. Then I'm going to swirl for around 30 seconds. Then I'm going to rinse using distilled water. After sterilizing the particular part of the plant that we want to do diagnosis on, the next step is incubation. And the incubation part require a media, or I can just incubate in a small amount of water. And in most cases, water to us is mostly used as a universal medium. We just put a small amount of water so as to create that moist environment for that particular bacteria or pathogen to thrive in. Then I'm going to use a tweezer that has been sterilized using 70% of ethanol, and I'll put that particular part that has been diseased on either our prepared media or just filter paper that is having moist water. The third stage is known as incubation. We'll just incubate for 24 hours, but in cases of fungi, we do incubate for a period of 3 to 4 days. After the period has already elapsed for those both pathogens respectively, we'll take the incubated sample and move to the second last part. We generally use two types of microscope. We have a stereo microscope. In other laboratories are known as dissecting microscope, and you have a compound microscope. The function of a stereo microscope is to see the type of the fruiting body or the mycelia that is present in that particular part that was incubated. And secondly, it also helps you to isolate that particular part that you want to get much more details under the compound microscope. Before we move to the compound microscope, I need first of all to look the type of fruiting body that is there and the mycelia, and I'm going to isolate that particular part of the pathogen that has grown. And I'm going to put a drop of distilled water. Then I'm going to use a cover slip to cover that pathogen before we view it under the compound microscope. Now, the main function of a compound microscope is simply to magnify that particular part that you had isolated. It's simply going to give you the much more details of the pathogen that we were suspecting to have caused a disease in that particular plant. And we use a collection of books known as Compendium of Diseases, simply to identify that particular pathogen, be it a bacteria, be it a fungi, be it a bacteria, be it a fungi, in different types of crops. As you can see, we have got different types of books that do help us or do aid us in identifying particular disease in a particular crop. Collections of diseases that had already been identified. So our aim is simply to know that the identification of that particular disease, what are the symptoms and how are they when viewed under the microscope. And once they have been identified, we simply now give back the control measures. We call back the farmer and give them the control measures. However, if you actually see a diseased plant, and if that particular plant is not by any means caused by a pathogen, we just give an instant control measure. And in most cases, that is where the nutritive part comes in. But if it requires much more of the disease diagnosis, we'll move to the microscope. Once you have identified which type of pathogen, we'll give the control measures. And if further research is required, that's when now we move to the glasshouse or the greenhouse.
This is the open international quarantine field where we carry out screening of wheat germplasm from partners. From partners means our collaborators from outside. We get material from CIMIT, we get material from USDA, we get material from Canada, from Uruguay, from Bangladesh, from India. Let me say it's a global germplasm collection. So when the material, what happened is a collaborator would want his material or her material to be screened against the UG99. So what we do, he gives a request of how many lines he wants to screen, and then we apply for a permit from KEFIS. When KEFIS gives us the permit, we send the permit to the collaborator, and then the collaborator sends the seed following the instruction on the permit. When the material arrives here, we now prepare the field and we plant them in this field. So as you can see here, this material is for main season. It's already planted, it has just germinated, and in this particular block we have the F4 and F5 generations. That means this material is still being selected. So we'll do the selection and then it will go to another stage until when it reaches the advanced stage. Then the other block there, we have started planting material from other countries. That one, the planting is slightly different from here. Like this one, each line is planted 8 meters long. But like the other ones, which are more or less advanced lines, each line is planted at 0.75 centimeters. So we'll do all the management that is required, taking care of the weeds, taking care of the insects, but we don't spray against the disease. So what we normally do, like what you are seeing, this line here is a spreader that is susceptible. So we will artificially inoculate this spreader or give it the rust disease, and then it's expected the disease will be moved into, will infect the lines. We don't inoculate the lines directly. Then when it is, we will keep on monitoring for the appearance and development of the disease. So when it's about 50 or 40% infection, we now come in for selection or we take the notes. So for each country, when we take notes for each country, we take the data back to the collaborator. Or if the collaborator is able to come to Kenya, he or she is allowed to score his own material. But at the same time, together with our partners, that is CIMIT, we use this facility for capacity building. We train scientists from, again, all over the world to come and train on how to take rust notes. That is, we are trying to standardize the notes taking so that it is the same for all countries in the world.
Side of the county line. We ain't rich, but we do it all right. Got my honey on my arm, Jesus in my